Well, I want to thank the Cowtown Hamfest for the opportunity to do a couple of different things. Yesterday, I did basically a presentation demo simultaneously. Today, we're going to do the traditional slideshow type thing, and but I do have one pass and one only today that we're going to try to work at about 10:30. So as soon as we get done with this, I'm going to run downstairs. That particular pass is going to be an FM satellite AO91, and we're going to meet in the southwest corner of the outside of the building, as opposed to the southeast corner like some of you saw last night. So we'll be down in the southwest corner, and it'll be just me and my arrow. Okay, we're going to talk about amateur radio satellites today, and that is me in my front yard and my arrow on the tripod with my FT847 and my laptop running SatPC32. And doing a linear satellite pass on RS-44. We'll talk about the different types of satellites here in just a couple of minutes here. Yeah, that's basically the agenda we're going to go through today. I'm not going to go through a lot of the history of AMSAT like I used to. It takes a lot of time. We can talk about that later. You can get that stuff online. But we're going to give you, hopefully, it's going to be quick, but we're going to give you some terminologies and some information that you can then continue researching and learning about, and it'll say, oh, I heard him say that in that presentation. And so anyway, I've been a ham for almost 40 years, 38, but I didn't get into satellites until 2010, but I had an interest, but I didn't think I could do it. I didn't think it was something that was accomplishable by a guy of marginal means, but it is. And just like anything ham, you can spend a heck of a lot of money or maybe not so much. But so I am blessed to be able to be here, and we'll go on from there. So getting started on FM satellites is what we want to start. Now, it is an easy on-ramp. They tend to be known as easy sats, but as some of you who maybe went to the demo last night, it's not always easy. It is weak signal work. It is not, kind of except for the ISS crossband. We'll talk about that later, but most of the other CubeSats and small satellites are well less than a watt of RF transmit power, and they can be anywhere from 300 miles if they're straight up to over 2,000 miles if they're near the horizon. So just go looking at half a watt at 70 centimeters at 2,000 miles, you get the path attenuation there. We're going to talk about what equipment to use, knowing what satellites are available, how do you know where the satellites are, what frequencies the satellites will be on, how do you track a satellite, what does that mean, what do I say in the different types of contacts and operating procedures. There are different types of satellites. We're primarily going to be talking about FM repeater satellites today, but there also are linear transponders for SSB and CW. There also are digital packet. There's some specialty modes like digital voice that have been used in the past. There's also a whole bunch of telemetry-only satellites on amateur radio frequencies. We'll talk about all that stuff. And of course, you can get a whole lot of information about all this on the AMSAT.org web. Oh, pointers don't work well on plasma TVs, so there we go. On the AMSAT.org website under satellite information. And of course, if you're an AMSAT member, and you don't have to be, but if you are a member, you can download this handy-dandy yearly updated frequency chart, which will give every active satellite that's up there. But even the 2022 one is outdated because of 2 recent Chinese satellite deployments that don't show in this list. Even as such, that's still a good resource to have. So what equipment do you need? Well, basically, you really want to create the best receive station you can. I could hear AO91 with this whip. I would probably have no success getting into it. Just not enough directional gain. So you really want something with directional gain. You also really want a radio, if possible, that can do full duplex, meaning you can listen at the same time that you are transmitting. You know, the D72 out of stock, out of production, Kenwood radio can do that. There's a bunch of FM mobiles that can do full duplex. Those are good options. You know, there are some all-mode transceivers that are out there that are good options, but or you can use two radios. That's another possibility. Since the Aero antenna over here has two different feed points, you can plug two separate radios into it. One for 70 centimeters, one for 2 meters, and work it that way. And there's a D72 like I have. It is a good radio. It can do GPS, can do APRS. It can do a bunch of different things, but there are others out on the market. Mobiles, like I said, like the Kenwoods, some of the ICOMs are really nice full duplex radios. I've used them before. They're pretty decent for that. And of course, if you need want a full featured rig, like the 9700 is the only production radio right now that can do all modes on 2 meters and 70 centimeters. However, you can use a TS2000. I have a trusty FT847 Yaesu 25-year-old radio design that is a really great at satellite operation. It's a little wimpy on the 70 centimeter receive band, so I always use a preamp even when I'm sitting on my tripod. Or you can use a pair of radios like the FT817, 818 pair, or that would, for 817s, if you use two of them, becomes the FT1634. That's another option. You know, as I said, put together the best receive station you can. You know, there are a bunch of antenna, several commercial styles like the Aero and the Elk. There are several good homebrew dual band antennas. That's the Aero, like I have in the corner. The base one is 7 elements on 70 centimeters, 3 elements on 2 meters, dual feed. So you can either use their little 10-watt duplexer, you can feed, if you want to feed a little more power into the antenna, use a bigger duplexer, or you do it, like I said, as 2 separate radio feeds. There's me on the coast of Maine, trying my darndest not to work any Europeans, but I didn't accomplish that, but it was still a lot of fun. The Elk antenna, which is a log periodic as opposed to a Yagi, it does work. I think it's a little more sensitive to polarity than the Aero is. So it's not my favorite, but I use it, of course. And there's another. This guy has some plans on the internet for homebrew, make it yourself antenna. That's pretty decent. And of course, our own from Fort Worth here, Kent, Britain, WA5VJB. Go search on the interwebs for WA5VJB cheap Yagi, and you'll get a PDF, and it shows you how to build that. He claims you can build it for $5. That means everything you have comes from the junk box. Well, if you have to go to Home Depot and buy some welding rod or some stiff wire, might cost you a little more, but it's an in-plane dual band with a duplexer you wind on a pencil. But it actually works really well as a dual feed if you don't do the duplexer and find the proper feed points on each of the 2 element things. It actually works, I think, better there. So there we go. Of course, adapting, making sure that whatever coax you're using and what connectors actually mate to the right, to the antenna. Of course, the D72 is an SMA. My older W32A by ICOM was a BNC. I have a whole tackle box of adapters. You can never have too many adapters, especially if you have a lot of combinations of possibilities of things to do. Like I have a couple of preamps, I have an FM amplifier, I have a couple of duplexers on my tripod. So, you know, it depends upon how I'm setting it up. You know, I may need to adapt the cables I have to the setup. So adapters are a good thing. A lot of other accessories. I forgot my voice recorder today. It's still at home. You know, a compass to know where north is. That's important when locating a low Earth orbiting satellite. A voice recorder, so because these, as you may have heard and may have will see, some of these contacts happen pretty fast, and it's hard to write call signs down while you're holding an antenna and a radio and trying to pay attention to the position you're at. Duplexers if you want an external. Headphones or headphone splitters. External speakers are a good thing. A cell phone is nice because there's good cell phone apps. We'll talk about that in just a couple of minutes. You know, this is just you know, talking about various different satellite tracking apps. This is how to know where the satellites are. You know, the cool thing about cell phones is there are just a lot of cool apps. Let me get out of, oh, that's not good. A lot of good apps out there that can tell you, show you positionally and give you azimuth elevation predictions and stuff like that. We'll show you some of those in just a second here. I'm trying to get my fingers on the right button. There we go. I'm not a big fan of SatSat. It's okay. Some people like it. I like, for the iOS, I like GoSat Watch. Alternatively, for Android, there's ISS Detector. And fortunately, within the last year or two, they ported a version of ISS Detector to iOS. So as a result, you can have the same functionalities. GoSat Watch is $10 one time. ISS Detector is $2.99, is free, but it only tracks the ISS. If you want to get amateur satellites and such, pay $2.99 one time, and you get all their add-ons, and it works pretty well. AMSAT Droid's free. There's some other new ones. Look for Sat for Android. Look, the number 4 Sat is a free Android app that can work pretty well too. Of course, for PCs, there's the venerable Sat PC 32, written by Eric Eichmann, DK1 TV from Germany. He developed the software back in the 90s, continues to support it, which is really cool, including for newer radios and such like that. That can control both the radio for frequencies and can control rotors. In fact, it can actually control 2 radios if you have one radio as a transmit and one as a receive. Mac Doppler, for you Mac heads out there, is a good piece of software as well. There's also gPredict, which I don't have a picture of here, but that has ports for Windows, Mac, and Linux. In fact, even ports for Raspberry Pi. There are also some other Raspberry Pi tracking softwares out there as well. So those are all good things to help you not only know where a satellite is, and especially in the case of these, how, if you have a all-band, all-mode radio, to be able to control the radio's frequency for Doppler correction, which we'll talk about in just a minute. But there's some web resources out there too for finding satellites. N5HYP on the right side, N5HYP.com, has a good graphical interface. One thing I will recommend about it, you need to select all passes, not visible only. Same thing for the ISS Detector app. You should select all passes, not visible only. If you do visible only, you'll only get the passes that occur near sunrise or sunset, and not not everything. Same thing for N5HYP. On the left is an interesting little application by the AMSAT Argentina folks called PASS. You go to amsat.org.ar and look for the PASS app, and it gives you a listing of the next 6 hours of most every amateur satellite that they track. And it also can give you not only azimuth and elevation information, but frequencies as well. So you can physically see the Doppler shift. And it's free. And, you have the capability of putting in your location, your grid square, or your latitude and longitude. And that's important for any app, whether it be on your phone, which can use the GPS. That one, which you have to maybe enter, those you have to enter manually. Unless you have an external GPS that's driving it. And these guys you have to put, this may get location, you know, that may get location information from your web position. This you'll have to enter it manually. But both of them are really good little web apps. And of course, the old-fashioned AMSAT.org past prediction. Go to satellite info, past predictions. This is how I started. You enter in whatever satellite you want. You enter in your longitude and latitude or your grid square, and you tell it, I want the next 50 passes, and it tells you when there are in text format. That's how I started. Didn't have apps, didn't have computer software, just had that. And that's how, and so you know when it's going to be coming over the horizon, which direction is going to be the highest elevation, and when it leaves. That's what you need to know. So there we go. So we're talking about the concept of AOS and LOS, acquisition of signal, loss of signal, and sometimes you call it max elevation or time of closest approach, which will also coincide with the time of the highest elevation in the sky. We're talking about low Earth orbiting satellites. Like the ISS is at about 260 miles up, whereas the AO7 is about 1,000 miles up, and Green Cube IO117 is like actually 3,600 miles up. So, but all of which have finite times each day where the Earth will rotate underneath the orbit. So you kind of need to know that information. But all these past prediction softwares, even the AMSAT text-based display will give you the information you need. Also, and then okay, I'm kind of showing here, it's a little hard to see on this monitor, but if you can, this is AO7. It's about 1,000 miles up, 900 some. Satellites here. This red circle is what we call the footprint. It's the area of the surface of the Earth that the satellite can see, and if the satellite can see it, we can see the satellite. Well, kind of see the satellite by radio. Now, moving on to the, oh, I did that wrong. This is the ISS running at about 260 miles, a much smaller footprint. So again, the higher the mountain you are, the farther you can see. All satellites have some form of an uplink. They have an uplink receiver and a downlink transmitter. In many cases, it's dual band. The uplink will be in maybe, say, VHF. The downlink will be on UHF, or maybe the opposite, maybe UHF up and VHF down. There is even a Chinese satellite just launched. It's called CAS-5A or FO118 that kind of goes back to the old days. It has a 15-meter uplink, at 21.4 something megahertz, and a 70-centimeter downlink. I haven't had a chance to work it yet, but I understand it works pretty well. And then we used to have some satellites back in the 80s that had similar types of HF ups, and they're Russians, HF up and HF down type things. So hold on here, I'm got a little lost where I are. Well, this is kind of talking about uplink, dealing with the Doppler shift, uplink calibration, or wait, this is the downlink side, yeah. Oh, here we go, yes. This is looking at like AO92, which is a 2-meter uplink, and it's a 70-centimeter uplink and a 2-meter downlink, excuse me. Because 2 meters, the Doppler shift on a 17,500 mile an hour satellite is about plus or minus 9.5 kilohertz, or 3.5 kilohertz for 2 meters. On 70 centimeters, it's 9.5 kilohertz. So in this case, we can leave our 2-meter frequency the same because all of these handhelds only have a 5 kilohertz step point. So either way, you're out of, even if you're at the beginning of the pass, you click 5 kilohertz off and you're probably out of the frequency. For 70 centimeters, the Doppler shift is about 9.5 kilohertz. So you do need to do some modification. If the uplink's on 70, you have to follow Doppler with that. Doppler shift for transmit is actually backwards of what we would think for Doppler shift for receive. Oh, I keep doing this. Yeah, no, wrong button. Oh yeah, it's a movie. I was going to back up and kind of show it. From GoSat Watch, a pass of AO91, you can see the footprint as it's moving forward, and now it's across the U.S., almost overhead pass. And of course, in about 12 to 13 minutes, it's gone. And then this is kind of sort of looking at how it would look from a sky view. You'll see it kind of seems to appear in the sky to move quicker the closer it is to us. You know, you got to know what satellite's gonna work, what frequencies they're on, what their quirks are. Every one of these has a little bit of a quirk. They're different. And the best way to learn about that is to follow, like I love to follow the AMSAT BB, the AMSAT mail list, because you learn stuff there. That's how I learned a lot of stuff in the first year, was by listening to what other people were talking about. And finding out some good information that way. The AMSAT News Service Bulletins, go to amsat.org, scroll down the page, look at the weekly compilation of interesting news items that they have there. You'll learn stuff about what satellites are new, what satellites are old. The Getting Started with Amateur Radio Satellites book that AMSAT produces now only as a digital download is a good resource, but even it's older. It doesn't have any information about the 2 new Chinese satellites. It doesn't have any information about the Israeli Tevel mission, which is actually a set of 8 CubeSats. It doesn't have, so finding that type of information out through the AMSAT mail list and through the News Service Bulletin and other amateur radio news sources that you can get is a good thing. Just so you know that the IARU has coordinated some specific ranges of frequencies. On the 2-meter band, the satellite subband is 145.8 to 146.0. On the 70-centimeter band, it's 435 to 438. There's even satellite subbands on the 15 and 10-meter bands. And there's satellite subbands on all the allocated amateur radio frequencies all the way up into the microwave bands. Future AMSAT satellites will try to return to 2 gigahertz range satellites, 5 gig up, 10 gig down. The European hosted payload on QO100, which is a geostationary communication satellite launched by the Qatarans that has an amateur radio payload on it, uses 2.4 gigs up and 10 gigahertz down for both analog and digital stuff. We don't have a geostationary here to work. There was hope for one a couple years ago, but it didn't really happen. Of course, FM satellites are, in theory, easy to use, easy to work, easy to hear, and easy to aim your antenna and easy on a credit card. Well, you can get into it. I just spent $400 on a 70 centimeter preamp because I blew out my older one. So yeah, it gets there. On the AMSAT.org website, this is actually a table that shows you, this is for the AO91 satellite. The downlink is 145.960. Well, when you're at the beginning of the pass, it's a couple kilohertz up. When you're at the end, it's a couple of kilohertz down. But you could leave your radio set at that. The uplink is on 70 centimeters. And you're actually doing reverse Doppler on this. You start yourself low because, okay, the satellite thinks it's, when we hear a train coming, it goes, well, we're standing still, it's going past us. Frequency starts high, it goes low. From the satellite standpoint, same thing. When it's transmitting, we listen high, it goes past us, we start going a little lower. When you're transmitting, the satellite thinks it's standing still and we're moving. So when we transmit up, we will have to compensate our Doppler for what the satellite thinks it's going to hear. So we'll actually start off low and move our way up. So I have 5 or 6 memories for the transmit side on AO91, and only one for the receive side. Here's SO50, which is kind of the opposite way. This is a this is a 2 meters up and a 70 centimeter down. So again, 3.5 kilohertz on the radio. Doesn't matter, leave a set frequency for the receive side, the transmit side, but you're moving the Doppler shift down on the receive side. And then there's PO101, that's another, that's a Philippines launched CubeSat that has both APRS and FM repeater operations, depending upon which mode they turn it on to. Of course, the frequency guide from AMSAT will give you a lot of this information. I'm hoping that they'll have a new one out by Hamvention time. And again, you can, you need to know, sorry. Yeah, they're talking about manual tracking. Again, just knowing where it starts, AOS, what its azimuth, where, that's why you need to know north, so you know where your starting point is. And then, at what azimuth your highest elevation will be, and then at what point on the horizon, azimuth-wise, it goes below the horizon. What do you say? On FM satellites, keep the communications short. Those of you who were involved with the demo yesterday heard somebody whistling, somebody continually just throwing their call sign out, even that sometimes people call in CQ. You don't do CQ on an FM repeater, do you? It's kind of sort of taboo. You don't do CQ on an FM satellite. You can do that on the linear transponders because they have much more bandwidth. You can have multiple conversations going on at the same time in SSB. So CQ is okay there, but not on FM repeaters. Making noise, when you have 15, 20 people on at the same time, if they all transmit simultaneously, all you get is noise. And even as such, it gets a little hard, and some of the guys are using a lot more power than they should. I'm going to do AO91 with 5 watts. I'm sure there's people using 100, and I'll have a tough time. In FM, the strongest signal wins. And if you have more than one, you get doubling, and you get lots of noise. So keep it short, keep it simple. Pretty much exchange call signs and grid squares. That's all you need. If you're collecting logbook of the world contacts and such, that's all you need is name and grid square. I mean, call and grid square. This is just some notes about what you might want to might want to need. You need to get all your stuff together. Know what satellites you're going to work. Know when they are. Know your location. Make sure your gear's working fine. You know, and you know, just you know, once you start doing this, it becomes second nature. But and use of memories is helpful. And of course, free hands is helpful too. And you notice one of the things, he's got his microphone up here. So it's going to be really hard for the folks to hear him. But it is doable. It really is. But my encouragement for getting started is to listen, listen, listen. See how it works. Listen and learn about the quirks for the different satellites, because knowing those quirks, like AO27 only being on for 4 minutes per pass, like SO50 having a PL tone to get into the satellite, but actually a different PL tone to turn it on. And I've been on passes where nobody has, every 10 minutes it has to hear that 74 hertz tone to stay active. So you'll go through a 13, 14 minute pass and somebody will forget to transmit that tone and the thing will go dark. For AO91 and 92, you don't use them at night because when they're in eclipse, because the batteries on both those satellites are about dead. AO92 is really dead. AO85 is really dead. 91 still works, but really we only want it used during the daytime because at night it's just running purely on battery power, and every time it hears a carrier, it will turn itself on, and that will drain the batteries, and the fear is that the weak batteries already will get drained too weak and they won't be able to turn it back on. So knowing those quirks, knowing those things that about every different satellite. So I encourage listen, listen, listen. There is lots of great places, like I said, the AMSAT BB, the AMSAT mail list, that get you that types of information. And Getting Started with Amateur Satellite book, the 2020 version, which is a little dated, and hopefully they'll come up with a new one in 23 here. But it still gives you enough basic background information to know. And again, there's more to satellites than FM. The linear transponders, okay. So you have a satellite that can listen. It listens to a swath of frequencies that might be 20 kilohertz wide, might be 30. In the case of AO7, it's 60 kilohertz wide. In the case of FO29, it's 100 kilohertz wide. You can have multiple CW conversations, multiple as-to-speak conversations. You can even do FT4, FT8 on any of those satellites down at the very bottom of the passband. With relatively low power, there are folks doing really well using those digital modes on satellite. There is the 896, the IC 9700 is good for all of that, except for 9600 baud packet. Can't do it. They have no desire to put it there, according to my understanding of ICOM. But they'll do 1200 baud packet. Don't know why. Nobody gets it. Of course, like I said, a lot of people. AA5VZ from down here has a pair of 818s now, and he's using them exclusively for satellite. They work really well for him. Software-defined radios like the RTL SDR as a receiver can work good. I have a FunCube dongle. Actually, I have one of both for receivers. The FunCube is a really good receiver. There are some transmit capable SDRs out there, but you're going to need to provide some form of external amplification because they only like put out 5 milliwatts or something like that. That's really not going to work for you. Again, tracking software for your radio is not mandatory if you have like a 9700 or a pair of 818s or whatever, but it helps because it will track and derive both the downlink frequency and the uplink frequency, and allows you the capability of sliding those one way or the other to be able to get and keep a, you know, with FM, you can be 5 kilohertz off and still hear the other person. With SSB, all of you who know that, you know that if you're 200 kilohertz off, the audio sounds real weird. So you need to be fairly close on frequency for that, with very step accurate Doppler tuning to keep that. And so SAT-PC32, Mac Doppler, G-Predict can do that. The fun thing about written by Eric Eichmann, DK1TB. Yeah, all the stuff's in English, but his error messages are all in German. So if something goes wrong, a box pops up and goes, "Nein!" which is a good laugh. And some of them are full sentences in German, so you gotta plug them through a translate program to be able to figure out what they actually mean. Or just email them. Eric still supports it. He will, on the BB, if you say, I got a SAT-PC32 problem, he'll respond and fix it. The recent Green Cube, now it's called IO117, that's a 9600 baud APRS style satellite that's orbiting at 3,600 miles. Really nice, big footprint. But because the uplink frequency is the same as the downlink frequency, which is kind of the way ISS, and on the same band, so the base version of SAT-PC32 doesn't work. He has a version of the program called SAT-PC32 ISS that worked for same band, puts your radio in a split mode. But the problem was there never was a satellite that used anything other than 2 meters for that type of operation. So he had to create a new version of the SAT-PC ISS program just recently to be able to allow working Green Cube. So again, it's kind of cool. I don't know, you know, hopefully he'll stay with us for many years, but that's cool. And again, you can do APRS through the ISS. The D74 is a great APRS radio. Of course, the D72 and many Kenwood and ICOM mobiles have APRS capabilities. NO104 has a PSK 31 10 meter to 70 centimeter FM downlink for PSK. So you can tell these are PSK signals that are Doppler corrected. This is a terrestrial signal that's not. So you can, that actually is kind of a fun mode. Or there's data only downlink. The FunCube people from England, they have their FunCube dashboard. The AMSAT, we had our Fox Telem software that would downlink the data under voice that was part of the Fox Satellites FM system, and then would collect that data and push it out across the internet to a warehouse. And that way, by aggregating the data from all the different receive stations out there, they got good full orbit data information about the health of the batteries, the charging voltage, the temperature of the solar cells, such like that. And then, of course, you can find out about all that stuff as well in the Getting Started with Amateur Satellites book, available by download from the store at amsat.org. Again, more information on there. We have a nice frequency chart that's more current than what you'll find even as a member benefit, the chart I showed you before, or the book. They have a chart for FM satellites, and they have a chart for linear satellites. They have a satellite status page. Again, more information. The blues indicate, well, okay, that's been heard. Maybe they even heard conversations or had QSOs on those particular satellites. that would be data only. Red is not heard. The satellite might be off the air or not on at that particular time. Some satellites have schedules, like I said. So you can figure out, AO7, for instance, has two modes. Has a 70 centimeter up, 2 meter down, and a 2 meter up, 10 meter down mode that, if it's in full sunlight, flips every 24 hours. So knowing which mode you're on, you can tell by looking at the status page for that types of information. And another benefit for being an AMSAT member, now those are free, but if you're a member, you get every other month a thing called the AMSAT Journal, which is also a lot of good information, as well as some good basic articles and then some good technical articles about how that's the grid square heat map for amateur satellite operators. The red ones are the grid squares that are more in demand. And that's all I got. So, questions. I'm sure I've driven you all nuts and you got brain bulge, but maybe you got a question or two to ask.
The 9700 icon, I called ICOM and asked if the new versions are supporting 9600 baud, but they said that yes, but then again, I haven't tested it.
No, unless they have come up with a firmware update recently, because since it's really an SDR, they have to build it into their software. And also, they would have to probably change their filtering to be able to handle the wider bandwidth. So, and that's probably in SDR, but still, the 9700 has been out for a number of years, and they still haven't implemented that aspect. Now, just talk, because Coke bottle bottoms, I may not see your hand, so just throw out your question.
Do you have this presentation posted on anywhere?
I do. If you send me an email, I will send you a Dropbox link to the PDF version. My email address would be N5HYP@ARRL.net. That just always works. So you can do that.
I'm going to record this, so this will get on the Cowtown Hamfest YouTube channel. Once I get done editing it.
Okay. Anything else?
Are the solar flares causing any problems for the satellites that are up there?
Well, okay, and a couple things. Okay, a really bad one or a really bad CME could knock the electronics out. Another thing that solar flares or high solar flux activity does is it heats up the ionosphere and thus increases the amount of drag. Now, that's not a real problem for a satellite that's 500 miles up, but it is a problem for, like, the FalconSat 3 satellite, which was a U.S. Air Force Academy project that had several different missions for the Air Force, but it also had amateur radio APRS capability, 9600 baud APRS capability. About 3-4 years ago, it was turned over to AMSAT purely for that. But its orbit is decaying now. I think I looked the other day, it's somewhere in the 170 miles. So once it gets into that range, the atmospheric drag, albeit small, grows the lower it gets. But with that heating of the ionosphere, it adds more pressure and more drag, and will probably hasten the deorbit of FalconSat. A couple months ago, Starlink launched a set of satellites that they launch them into a low orbit, and then they have little thrusters on them that they take them up, slowly get them up to the right orbit. There was a big solar flare that happened right after launch, and it caused enough drag that wasn't anticipated that caused those satellites to deorbit within a day or two because they hadn't gotten to the altitude that they needed to be. So yes, that can affect. What else?
Any way to take advantage of passive re-radiation off of those SpaceX satellites?
I don't quite get the...
So I mean, like kind of an EME thing, could you bounce RF off of one of those?
Well, okay, we're talking... AO91 is a 10 by 10 by 10 centimeter cube. Go downstairs and look at our CubeSat simulator. That is the Fox satellite. Not much of a target to bounce off of. You know, if the moon is a 7% return on your reflected energy, yeah, you're not going to get much passively off of a 10 by 10 by 10 centimeter CubeSat. So, no, that's not. Even there have been a little bit of experimentation to see if something as big as the ISS could provide RF reflection, but that was really not very successful either. Again, even the ISS is kind of porous. I mean, there's maybe a lot of surface area, but if the solar panels aren't pointing your way or flat to you, there's a lot less surface area. So no, passive reflection is not an efficient mode.
Oh, what about pan and tilt stands? Any recommendations for that?
Pan and, oh,
Yeah, movable stands?
tripods?
Yeah.
Yeah, I mean, I have one downstairs. I've got a friend printed a 3D printed mount for the block for the shoe on my tripod. So yeah, I can use the tripod to tilt it up and down, and because the tripod has tilt. I mean, if I'm holding it, I actually keep the support bar on because I can rest it on my belt. Makes it a lot easier. But rather than just hand holding the whole thing, which I can do too. But tripods make it nice because it does free a hand up. And now rotors, there used to be, I mean, there's several designs out there. If any guys know Jack, AA5VZ, he built an ASL automated rotor package on his own. Another friend of mine, Guy, K1GBD, who lives down in Forney now, built a rather different one, and he's actually redesigning it to use stepper motors. So there's some good homebrew projects. Portable rotation used to have a commercial thing geared for the Aero or the Elk, and they got out of the amateur business. They still sell their stuff, but they don't market it to hams. And actually, Jay back there had one and had issues with it. He's got whole sagas about dealing with his portable rotations. So, you know, it wasn't a panacea either. So sometimes going simple is better. But again, I do like Jacks. I do like Guys. Both their homebrew systems do a really nice job of automatically tracking sats to give you a little more opportunity to concentrate on the radio side. For me, if I got my tripod and I got my 847, I have to run out, move the antenna, run back, do the QSO, run back out, move the antenna, run back. So get your exercise that way. But it does make it a little inconvenient. The one thing everybody's so concerned about, do I have to just aim precisely at the satellite? This thing has like a 15-degree or more beam width. If you're anywhere in the ballpark, you're going to hear it. The pointing is not an exact science. and people go, oh, I got to keep flipping you around all the, well, usually there's you'll want to flip it a bit to deal with polarity. And some satellites have so much spin that you can't follow it anyway. So you just find something that works good and leave it alone. There's challenge, but it's fun. So hopefully, as I said, I'm going to do the one pass for the day that's left that will work during the time frame of this Hamfest is starting at about 10:30 down, and I'll be on the southwest corner of the building because it will be a slightly southwest of south to a max L of about 40 some odd degrees to slightly west of north. And so that will actually be not a bad one because it'll catch most of the central and western U.S. And so there's my suggestion is if you try West Coast passes, there's fewer people out there, so the traffic's a little less. Maybe some of the extraneous interference is less. You might have a better shot at it than if you do an East Coast facing pass. And where there's a lot of people, a lot of hams, a lot of interference. And there we go. And of course, if you ever got questions, email me. And we do have 2 nets a week in the Dallas-Fort Worth area where we talk about amateur radio in space. If you live on the east side, the Dallas net is on Tuesday nights at 8 p.m. on the DARC 146.88 repeater every Tuesday at 8 except for the first Tuesday of the month because that's their club meeting night. And then for you guys on the western half of the Metroplex, the Arlington repeater on Wednesday nights at 9 p.m. We do the same thing. I'm net control for a number of them on both repeaters. So there's pretty much anywhere in the Metroplex here. And the DARC one, because they're on Echolink, can be also listened to from other places via the W5FC-R Echolink node.
Do you have a recommendation for a cheap gadget or phone app that does pointing to do your azimuth and elevation?
Well, what phone type, do you have, iOS or Android?
Android.
Look for SAT, LOOK for SAT. People have recommended they like. I mean, if you spend $2 and buy $3 and buy ISS Detector Pro.
Not only give you the numerical stuff, but it will actually.
Oh yes, it shows you both of them will show you. At least they'll show you compass plots. Hold on, I can't.
Can you actually
Yeah.
Point the phone in the direction you want to be aiming at?
Yes. Okay. Here's GoSat Watch in its Skyview mode. Right now there are 2 satellites that I can tell where north is, and right now I'm supposed to be tracking Tevel 3. That's where that was the last one. If I click on that guy, there we go. That's one of the Tevels up there.
So you rotate your phone and move it.
Yeah, but it does follow you. Yeah, it rotates around.
I mean, if you aim it at the sky.
If you aim it at the sky, you can
literally show where.
It literally show you, like right now I'm facing, well, let's see, am I really facing the right direction? I don't know, but I can see the sun, I can see what's below the horizon, I can see that those guys are just a bit above the horizon, that direction toward the northeast. So,
What's the name of that again, please?
this is for the iOS GoSat Watch.
ISS GoSat.
No, this is called GoSat Watch.
GoSat.
The other one that I like is ISS Detector, and that's available for both Android and iOS. But for Android for free, Look for Sat is good. I have never used it because I'm not an Android guy, but it's it's got some. It had some good recommendations. There was somebody on the BB the other day was asking, "Hey, what's a good Android satellite app?" And about 4 or 5 people came back with their comments, and several of them liked the Look for Sat. So.
We've got a pretty good room, Tom.
Yeah, I'm good. I'm done. Thank you.